Hello, hi, and welcome to a new DIY video from EFY. This is Shad, your host for today, and in this video, we'll be talking about power banks. Power banks are of different types, and it can be used to charge different kind of phones, even EVs, or even to power something like a grid, which is usually used in solar uh, solar farms. So in this video, I'll be showing you how you can make your own DIY power bank so that you can utilize it to charge your device at a later stage, or you can use it to power your MCUs or IoT devices. So before starting the power bank, let us understand the three parts of a power bank. A power bank can be divided into three components. First is the most important thing, the battery pack, which stores the energy. Apart from that, there are two more components: the input side, which is used to charge the battery, and the output side, which is used to utilize the power stored in the battery and provide it to use it in our devices. So mainly we'll be talking about the battery pack and how it's made. But before going there, let us understand why battery pack is very important. So recently we have all heard about a lot of EVs catching fire. There are news that EVs from big manufacturers are catching fire. Some EV manufacturers have recalled 3,000, 4,000 EVs of theirs because of simple battery issue. And this is caused because of lithium ion cells. Previously, there were some devices like phones which were banned in certain airlines because of, again, that is because of lithium ion cells. So lithium ion cells are very important. They have a good storage capacity, but the main issue is they are very volatile. So whatever you do, they might catch fire. If you overcharge them, they might catch fire. If there's a short circuit, they might catch fire. If you poke them, or if there is a mechanical damage to the cell, it might cause fire. Whatever you do, it can start a fire. Even if in a battery pack, if there are two cells which are having different voltages, very different voltages connected in parallel, then it might start a fire. And this is because of thermal runaway. So thermal runaway, once started, is a chemical reaction which keeps on increasing the temperature of the battery to uncontrollable level. And in this case, the battery can cause fire and just might damage. So to stop this, we have a system called battery management system. It is a device. As you can see in the screen, there is a battery management system which I have used in a 4S cell, a 4S battery pack which I have made, and I'll show you how you can make it on your own. So battery management system basically helps you to make, or helps the battery to stabilize it, to provide all the better parameters for each and every cell. It monitors different parameters such as temperature, voltage in each cell. Apart from that, current drawn, if the voltage of the cell is increasing, if the cell is undercharged, or if the capacity of the cell, which should not go below a certain threshold, is met, then the BMS stops the process. So BMS basically provides the cell and the battery pack perfect parameters to make sure that it is stable. Now, coming to the battery pack. So battery pack can be designed in certain ways, and first we'll see how we can design a battery pack. So let's get started with designing a battery pack. So the component for designing a battery pack, this is basically the battery module with BMS 4S battery module, which I'll be showing you in the later stage. So for designing a battery pack, the components we need are obviously a cell. So in this case, I'm using a Samsung cell. It's Samsung 26J. It's a 2600 milliamp hour capacity battery cell, and it's pretty good. Apart from that, we use cell spacers. These are like little Legos which can join on the cell, which holds the cell. So you can take a couple of Legos, or as many as you want, and just join them to form a battery pack. Apart from that, we also need a nickel strip, as shown here, which is used to connect the terminals of the cell, and we need some soldering paste and soldering wire. Now, the best thing to use to make a battery pack is using a spot welder. But since spot welders are pretty expensive, so we can also use a soldering iron, although it's not advisable. But I'll show you how you can make a battery pack of your own. So using a soldering iron, the first thing you should do is take a cell and place it in a stable surface. So I've used just a cell spacer to do so, and then scratch the top part, like the electrodes of the battery, to expose the layer so that the solder can stick to it nicely. So as you can see, I'm scratching the surface of the cell. Now after that, apply a decent amount of solvent paste. It will help reduce oxidation and will make a better solder. Now when you are making a silk, try to make sure that the soldering iron is very hot. Apart from that, you should also make sure that you don't keep the contact for a very long time. So I'll show you how you can do it. So first melt all the soldering wax, and then using the solder, apply a decent amount of solder and try to make sure that it sticks to the surface. Now you can see that why I have scratched the surface, because unless you scratch the surface, it won't stick to the surface. So there's a small amount of solder which has been placed on the surface. Now cell can be connected in series or parallel depending on what configuration of battery pack you want. So suppose if you want to connect them in parallel, then you'll have to use the same electrodes. Like this one is having the negative side, so I use another cell with negative side. And if it's having the positive side, like if I want to connect it in series, then the positive of one cell will be connected to the negative of another cell, and I can connect it here. So after that, we'll place this cell spacer, and we'll also do the same with the nickel strip. So we'll take the nickel strip, we'll cut it according to the size of our cell. So we'll need this long of a cell, and then we'll cut it of this length. Then after cutting it, we'll make sure that we also we also stick the solder to a nickel strip. So we'll try to stick the solder paste here, soldering here, and make sure that it just gets sticks to the surface like this. Now since I'll be using the second cell for another thing, so I'm just taking it off for now, because I just need to show you how it is done. Now after doing this, make sure that both the sides are soldered and I have the solder connected. Now take the solder iron and put the solder here and press this hard enough so the solder will stick to it. As you can see that the connection is made and it is pretty fine. The connection is not coming out, as you can see. So this was just for demonstration how you can do that, because at the end of the day you have to make this battery configuration as per your need. So for that, just a second, sorry, I'll just take off my soldering iron. Yeah, okay. Now we can connect as many cells as we want. Now coming to this battery pack, so once we have a battery pack ready of the specific configuration we want, we'll just have this battery pack. Just to let you know that I've already connected the BMS previously, because it will take time and it won't look good during our DIY session. So the connection of the BMS are shown in the slide, as you can see. Yeah, thank you. So this is a positive terminal, this is our first cell, and this is a negative terminal of our battery. So we are taking this as a first cell. So the first cell, we have connected a negative to the output of BMS, B minus, and the positive of first cell is connected to the negative of second cell. And same way, the positive of second cell is connected to the negative of third cell, and the positive of third cell is connected to the negative of fourth cell, and the positive of fourth cell is connected to the battery management system positive, where it's showing B plus. So you can see that it is a series connection because all the cells are connected in series. Now, while connecting the cells in parallel, when you connect the cell in series, the voltage increases. Like a single cell will have a nominal voltage of 3.7 volt because it's an NMC configuration, NMC chemistry, and each cell is having a nominal voltage of 3.7 volt and it goes up to 4.2 volt. So all the cells are charged. So you can see that since it's in series connection, so we can multiply 4.2 by into 4 and we get the voltage of this battery pack. So I'll try to show you the voltage of the battery pack. I think you can see my screen and the screen of the voltmeter, the multimeter, sorry. So you can see that the voltage of the battery pack is 16.7 volt. So almost all the cells are fully charged. Now, how do we connect the BMS? So as already shown that B minus and B plus are connected to the negative and positive of the battery. Now, we also need to connect all the single cells with BMS so that the BMS knows the accurate voltage of every cell. This is a very simple BMS, but there are other BMS which are advanced, which have communication protocol in it, as well as they monitor temperature and even do cell balancing. Active cell balancing is basically done. There are two kinds of cell balancing, active and passive, but this model doesn't have any cell balancing feature in it. So in the first case, the negative, as you can see in the image, that the negative of like the positive of first cell is connected to VL. The positive of second cell is connected to VM, and the positive of third cell is connected to VH. That's how we make the connection for the BMS. After making the connection, the BMS will make sure all the cells are in accurate voltage, in the voltage it should be. Now I'll just show you how it works. So there are many kind of features in the BMS, like they have overcurrent feature, they have short circuit feature. So I'll just show you how you can make. So I have already connected a switch in series with the BMS, and I've used a XT60 connector, which is a really good connector, which is also used for automobiles. Now, this is a 12 volt battery pack. Like this can run on 14 to 16 volt. This light. So I'll connect the light with my battery pack, and I'll show how it works. So as soon as I switch on the connection, it starts glowing. Now I'll just show you the short circuit feature of this board. So as soon as I connect both the wire, because of the short circuit, the BMS stopped the current flow. Until and unless I stop the connection completely and restart it, the BMS won't allow the current to pass through the battery. So as you can see, the BMS just protected this battery pack from a short circuit. So that's one of the features. Now there are other features in a BMS, but right now we can't show it because it's just a live video. Now, how can you make a single cell battery pack? So in that case, this is a single cell. Now we need to charge the battery. So the main important thing while having a battery pack is that you have to charge it. And as I've already mentioned, that charging the cell is very crucial. So there are two charging modes, one is CC and one is CB. So we usually use modules such as this, which can be used to charge the battery pack. So this is TP4056, a very common module. This is using USB B mini, but we also can get it in USB Type C. So I've already attached a TP4056 in this cell, and I've used this LDO, which gives a linear voltage of 3.7 volt. So as you can see that whenever I'm switching it on, the linear LDO is starting working, this linear voltage module. Now we can charge this by using our regular C-type cable. So, sorry. As soon as I plug in, it shows that it is completely charged. The battery is fully charged. But if we could have charged the battery without using this, but that might have damaged the battery. So that's why we use a module such as TP4056 to charge a battery pack. And this is the basic or the most simple type of DIY power bank we can make. So the connections are very simple. So this is a 3-volt power bank. This is basically a 3.3-volt power bank, and I can show you the output that the linear voltage regulator just gives a output of 3.3 volt. So this is the positive terminal, this is the negative terminal. As soon as I connect it, you can see that the voltage is around 3.3 volt. It's around 3.2, 3.3 volt. And we can also use a LED to see that it's glowing, because this LED can work on 3 volts. So this is for you should always check whether like the polarity of the outputs. So this is my LED, the longer leg is the positive output. So you can see that the LED is glowing, so it's giving a perfect output. Now this is one of the most easiest battery pack you can make. So all you need is a TP4056, a lithium ion cell, a switch, and in this case I've used a 3.3 volt voltage regulator, but you can also use something like this MT3608 module. It is a boost converter which can boost this output from this cell, which is 4.2 volt, to something like 5 volt. There are linear output regulators as well. One is this DIY power bank, which is having an input of 5 volt and which is storing the energy in this cell at max of 4.2 volt, and the output coming from this battery pack is 3.3 volt. So these kind of battery packs can be used for certain circuits, like for using in Arduino Pro or other MCUs, or more many sensors use 3.3 volt input. Now you can already replace this module with this, as I've already told, MT3608, to make it a booster circuit which can be used to charge the battery of a phone. Now you can also use two cells to I'll use two cells and I'll connect them in series. So this one is already connected. So this one is the positive terminal and this is the negative terminal of the cell. So I'll connect the negative terminal of the cell here and the positive terminal of the cell here, and the output from this will be around 7.2 volts, because these are two cells, these are two different cells I've used, and they are connected in series. So I'll just try to show you the output, and the output here is, I hope you can see the output. So the output is 7.8 volt, as you can see. So these two cells are connected in series. Now how can we convert this thing into a 5 volt output? So the best thing you can use is a buck converter, which have a high efficiency. But if you don't have a buck converter, you can also use something like this LM7805. So this LM7805 module just gives an output of 5 volt, and it works from an input of somewhere from like 7 volt to 25 volt. I've connected USB type A is female connector here as well. As you can see, this is the USB type A, and the corner two pins here are for power. This is for VCC, and this is for ground, the corner pins, and the center two pins are for data pins. So I've just connected the last two pins, the power pin of this thing. Now I'll show you the circuit diagram of 7805 and how we make the connection. So this is 7805, and we usually use a capacitor in parallel to the input and ground, and also output and ground, but we don't have to use it here because the uh, input is very close to that. So we do it to remove the transient voltage or ripples, but right now we are using it for very small distance, so we don't actually need it. So now the first pin is the power input pin, V plus. So I'll connect, and the second pin is the ground pin. As you can see, I hope you can see it, that the ground pin is connected to the negative of our USB connector. Actually, the positive pin is connected to the USB connector, and the ground is connected to this ground of a USB connector, as you can see. Now I'll connect the ground pin to the ground pin of this, ground pin to the center pin of 7805. I hope it got entered correctly. And the positive to the positive of 7805. Okay, now our connections are done. Let's see the voltage between ground and the positive input and ground and the output. So the voltage between ground and the positive input is, sorry, it's 7.75, and ground and the output is, it should be around 5 volt. I'm unable to connect it because it's pretty difficult to see. I hope that you understand that 7805 is a very linear voltage regulator and it doesn't have any problem with this. So now, as I've shown you, I don't want you to make a single power bank, or I did not intend it to show you how you can make a single power bank of a single configuration. I wanted to inculcate in you a idea that you can use a battery pack to make a power bank of your own, as with whatever configuration you want. So the input part and the output part can be used as like you can use a power electronic module such as a buck converter, boost converter, or anything to make a power bank. And the center part, that is the battery pack, you need to make the battery pack as I've shown. It's always better if you make a large battery pack using spot welder, but if you don't have a spot welder, you should use a soldering iron of high quality and high temperature, like 50-watt soldering iron or 60-watt soldering iron, because you don't want to keep it for a very long time. Now the main thing is that you might say that this is a 5 volt supply, but can it charge a phone? Or there are different chargers. Are the chargers intelligent or the phone are intelligent? So no, the chargers are not very intelligent. Chargers basically just provide a 5 volt output, and it's your phone and the internal circuitry of your phone which detects whether the charger is compatible or not. So most of the phone chargers we have, like in iPhones and all, they usually have the power pin is same, they are just giving the 5 volt output, but there's a resistance between data pins, D plus and D minus. So if you can manage to know the proper resistance between two pins, what the company is using in the charger, then you'll be able to charge that with the speed, with the proper speed. So I hope that this is clear. If you have any doubt, I'm open to questions. So basically, the solar system's power battery management system is almost the same. The working is same. They also do the same things, but they are more advanced. They usually use communication protocols to make sure that all these things, to make sure that all the battery packs and all different solar modules are communicating within each other. And if there is some sort of problem, then the it can be communicated to a user as well. But basically they are the same, they're just more advanced. The recording will be available on the YouTube, and you can have more questions and you can post the questions there as well. So if you are watching it at a later time and could not question me during the live session, then you can post a question in the YouTube in the comments, and I'll be more than happy to answer that. Okay, thanks for watching the video. I hope you all enjoyed it and learned something new.